set of graphs, so 8, 5, which is tangent, cotangent, secant, and cosecant. Now it's similar how to find the amplitude and your shifts left and right and the period, just like sine and cosine, but now we have 4 more, and they have different shapes and such. So let's start here with tangent. Just like as if I have sine or cosine, I'm still going to use the yellow triangle or yellow dot to adjust the amplitude. So I move that up to 1.5. And then the period, or the left and right, up and down, I guess I would check that first. I'm not going to move it left, right, up, or down because there's no numbers subtracting inside the parentheses or outside the parentheses. So this right here is just the b value to affect the period length. Now, because it's tangent, instead of using 2 pi over b like sine and cosine, we're going to use pi over b. Same thing when I'm dividing with fractions, you can use the same copy dot flip. We'll end up doing pi times 2, and that is equal to 2 pi. So I would change the length of the period to 2 pi, and we would be all done. Okay, let's take a look at a cotangent graph. Cotangents are a little bit trickier, one extra step to them due to the asymptotes, the vertical asymptotes. So cotangent has to start with the vertical asymptote on the y-axis and end with a vertical asymptote at the end of the period. So it should be 2 vertical asymptotes within 1 full period and the curve in between them. Now I can take care of the amplitude just like I would with any other trig graph. Move that up to 2 due to the number at the front of the function. And then to calculate the shifts, I look for minus or plus, and the inside parentheses are outside, but it looks like it doesn't move left or right or up or down. This here is just a b value multiplied by the x. So b is pi, so I'll do pi over b. Since it's cotangent, full period is pi, like tangent. And I'll have pi over pi, which is equal to 1. Now, right now, I can actually see that the period is already 1. So I actually don't even need to do anything to this graph. So I'm done, which is nice. So vertical asymptote at the beginning, second vertical asymptote at 1, the end of the period. Okay, let's take a look at a secant graph. Secant and cosecant are back to 2 pi periods, and they have a bunch of these parabolas. They are the reciprocals of sine, cosine, just like tangent is reciprocal of cotangent. Now I can change the amplitude just like I would, but in this case, because there is no number in front of the secant, it'll stay at 1. Now, something to be aware about amplitude, if you haven't caught on previously, is it doesn't matter whether it's at -1 or +1. I never cross over, otherwise it messes up the shape of the graph. So if it's down here in the negatives, I just put the amplitude at -1 or -2 if this was a 2. Otherwise it messes up the shape. So it does not matter whether it's sitting at -1 or +1. It's the absolute value from the middle. Now next here I'm going to do check if there's shifts. There are no shifts, so I'm going to take care of the b value, which is the period. B is 4. So I'll do 2 pi over b, 2 pi over 4, just 2 pi fourths. 2 pi fourths reduces to pi halves. 2 fourths is a half, so pi halves. I'll adjust my red dot into pi halves, and I will be all done. Okay, now we have a cosecant graph, and these ones are a little harder, like cotangent with the asymptotes. The difference with cosecant is you have an asymptote at the very beginning of the y-axis, you have one right smack in the middle, and then you have one at the end. So there's actually a total of 3 asymptotes for one complete cycle or period. And then at the beginning of the period will be an asymptote, and the end of the period will be an asymptote. So this third asymptote, that should be the end of the period. Now I can take care of the amplitude just like it would, -1/2, since the amplitude is 1.5. And no shifts left, right, up, or down, because there's no numbers subtracting or adding from the x or outside the parentheses. So this is just the period. So I do 2 pi over b, and 2 pi over 4 pi is 1/2. So that means this third asymptote needs to be clear over here at 1/2. It's going to squish it quite drastically. Now the trick to get the asymptote right there, because it's kind of tricky if I try to just drag this right now, it's quite challenging to get the asymptote right there. It gets really messy. So the trick is, and I'm just going to reset this, is to move the blue diamond to the middle so we can pretend for a minute that this is a secant graph, because secant starts with the parabola. And that means the third parabola would be at the end of the period. So I can drag this into 1/2 because we just calculated the period is 1/2. Now, before I say I'm done, this is still a secant graph where it starts with a parabola, but we want it to be cosecant, so I need to move this back over so that it starts with the asymptote, making it a cosecant graph. And then as you notice, the third asymptote's at 1/2. It goes quite nicely if you do that trick and pretend it's secant for a minute. Okay, let's try a tangent graph with a shift. So I take care of the amplitude. Period is just 1, so I don't need to adjust the red dot. And then +2 means I go up 2. And then -4 pi is right 4 pi. So I will just take the blue dot and move it all the way over to 4 pi. And we're done. Now cotangent, I'm hoping we have another one to practice. This one here doesn't adjust the period, but it's good to practice since the asymptotes kind of mess it up a little bit. So let's practice this one here. First, I take care of the amplitude, move that to 2, and then the midline up to 3. And then the shift is right pi 4. Now the tricky part about this is the blue dot is not a 0-like tangent, so I can't just drag this to 4 pi. I have to drag this 4 pi from where it's currently sitting. So because it's already at pi halves, I need to add a half to 4 pi, which is 4.5. If you think about 4.5 as a fraction, that's 9 halves. So I'm just going to drag it clear over until it tells me it's 9 pi halves. Or you can even say, oh, here's 4 pi, and I just need to go a half more because it was currently sitting at a half. All right, now I'm curious if I can find a cotangent graph where it actually makes you adjust a period, because the one that we did together was too easy. So I'm going to regenerate this one and see if it gives one that is a little bit harder to end on. Okay, so this one here, take care of my amplitude, and then period is pi over 2 pi, which is 1/2. So that means the second asymptote needs to be at 1/2. Now you could do what we did with cosecant, bring the red or the blue diamond to the origin to pretend that it's tangent for a minute. And then I bring the red dot into a half. That's the length of the period. It could be a -1/2 or +1/2, doesn't matter. But because it's cotangent, I need to move it back so that the asymptote is the starting point in the y-axis. And then you notice the second asymptote is at 1/2. All right, that will conclude for this video. Hopefully that helps. And we'll see you guys around.